Really thankful to the organizers, sponsors, and of course for y'all to come out and see us present. It's truly an honor. It's my first time in Brazil, and it's a wonderful community. I love this. So I'm going to talk about becoming a security-minded developer. So hi, I'm Adam. I'm the head of security at NPM, a small JavaScript startup. You might have heard of us. Chances are every one of you that does anything with JavaScript, well, we know you use NPM. I joined NPM back in February when my team at Lyft Security was acquired. And prior to that, I ran a penetration testing company for 10 years. I've worked with NPM for a long time. In fact, my first pull request to any open source project was to the registry, to the NPM registry to fix a security bug. So I've been very involved in the security of NPM for quite a long time. So it was fun to have this come full circle and now join the NPM team where we can work on security efforts full time. So a little bit of a warning, this talk comes with some assembly required. It's going to require you to think. I know it's the morning, but it's going to require you to put some pieces together for yourself and draw some conclusions for yourself. So why am I here? I'm here because security is on our minds. And I know that because we ran a survey. NPM ran a survey this last year, and 87% of y'all are concerned about the security of the code that you write. I also know that basically I've been talking at security events, or developer events since 2009. And just about every conversation that I enter into at one of those events, if I get into a group of people and I introduce myself and they find out that I have something to do with security, it hijacks the conversation. Whoop. We want to talk about security. We want to know what we can fix as developers to reduce the bugs that we have. We want that one hack, right? We want that one little trick to make things better. And so I know that it's on our minds, right? It's also on the minds of our users, right? Just this year, Risk-Based Security has a mid-2018 report. 2,300 disclosed breaches. That's disclosed, right? There's many more to come. And 2.6 billion records of data that were breached. Our users see these headlines. They're impacted by these bugs. T-Mobile announced a breach yesterday. 2 million users impacted, right? So our users are impacted by the choices we make as developers, right? The bugs come out of our fingertips and into our editors, right? And so they're impacted. Our bugs that we create impact real people. And I'm really here to get you excited to make more secure software, right? Like I don't, if you take one thing away from this talk, if you take just one thing, I'll be happy, right? So, and what I'm going to do to get you excited to build software, more secure software, is to give you some tools and techniques to do so, the best that I can. So we're going to kind of go back to the beginning and let's go back to the basics of what security is. And the reason why we're going back to the basics is because the basics are what we're still getting wrong. The Verizon Data Breach Investigative Report, the VBIR, still says that companies are getting owned because of weak passwords. We're getting compromised because of exposed and misconfigured services, right? Minor bugs that get chained together create a breach, right? So let's talk about what security is, just to give some perspective. So security it's not a binary state of secure and insecure, despite the words sound that way. It sounds like you're either one or the other, but it's actually varying shades of gray between insecure and somewhere better than that, right? We never reach that 100% secure point. That's an impossibility. We actually, you can buy insurance to guard against that last little sliver, but you can never reach that. Some visual representations of security that you may have seen before. I love this picture. This represents insecurity, right? And something we think of the weakest. We're only as strong as the weakest link. This is one of the reasons why we do defense in depth and we have multiple layers of control and security is because of this sort of concept. I like to think of security more, though, as the Penrose stairs. And the Penrose stairs is an optical illusion, right, of always going up and always improving. And this is representative of our discipline as developers, right? We are always learning. We're always taking a step up and a step forward in perpetuity, right? Or maybe we're just walking on an escalator backwards forever, and if we stop walking, we end up down at the bottom, right? So again, a representative of our discipline forever. And sometimes as developers, it feels a little bit like this. We're in that optical illusion, and we're just sort of like tumbling, falling up the escalator, trying to figure out what we're doing, right? And as we're building software, right? And this the security industry likes to say, like, build security in at the beginning of your. We're just going to let this keep going. Build security in at the beginning of your process, and sometimes we're just trying to figure out how to make the feature work, right? And so, and now you have to worry about security and performance and design and all these things, and it can be rather difficult. So again, security is a journey, not a destination. It's something that once you start thinking about these things, you will think about them forever, right? Once you start down this path, it's part of your development career forever. This journey is about shipping code, right? This is apparently how I draw code, little box. It's about taking that code from conception in your head, through your fingers into your IDE, where it's going to join many other like NPM packages, right? Where it's going to join other JavaScript, and then it's going to end up being committed to a repo, right? Where it's going to join the chaos of all the other team members committing to that repo, right? And then it's going to hit production, and it's going to interface with your user who throws more chaos at it, right? And that, getting from that idea to production, right? It's fraught with challenges. Just getting the idea from your head into an editor, right? Like it's depending on your mood that day, depending on like your past experiences, it's going to affect that process. So let's see. Let's look at a kind of like my framework for thinking about how we can get to becoming a security-minded developer, right? And really, it's about that discipline. It's about our habits, right? It's about and then using process and tools to influence those habits, because habits are hard to change, right? Like we are creatures of habit, and breaking those habits can be hard, right? Just like one habit you might have is sleeping in late, right? And if you want to become an early bird, right, you might set an alarm, right? Setting an alarm is a reminder, right? So building new habits comes with three R's: reminder, routine, and reward. And so reminder is that alarm going off. It triggers that behavior, right? It's a reminder to do something. You're telling yourself, hey, do something. Same as you'd set a calendar reminder. Routine is the behavior that you want to take, and we have two choices, right? We set the alarm, we can snooze, right, or we can get up. We can do the behavior that we want to take, and the reward, right? We get something out of the behavior. For us as developers, we hopefully want more performant code, less bugs, more secure code. So to support those things, right, the reminder, the routine, the reward, we've got sort of process and tooling that we can talk about to set up those reminders and then do those routines and then hopefully have better code. So let's talk about process. And when I think about process, like processes are really boring and everyone hates process. I think about checklists, right? And we have a lot to learn from other industries in terms of checklists, right? So I love this tweet. So surgeons didn't want to use checklists because they were too full of themselves, but then accidental deaths fell by 30 to 50% in hospitals that adopted them. You know who else suffers from the same hubris? Programmers, right? And there's another one. There's a book called The Checklist Manifesto. I'll mess the name up here. Atul Gawande. And I learned about this from the Safety Culture blog about airlines, right? So airlines, one of the most safe form of travel, they have clearly defined choke points in their process, right? They have these places of reminder to do certain processes, and they define sort of these checklists to have clear checkpoints that we should pause to determine what checklists should be used during those checkpoints, and then to keep the checklist to be like 5 to 9 items. Don't make it this monstrous task every time. Have it bite-sized. You're going to be more successful. So let's look at some of the things, places in our process from idea to production that we can kind of insert ourselves that might help you. And the first one that I come up with is threat modeling. And who's here heard of threat modeling? Anybody? Okay, a couple hands. That's good, right? Basically, threat modeling is your opportunity to think a little evil, right? It's your opportunity to think ahead about what could go wrong, weigh the risks, and take appropriate action. Sometimes, as an attacker, we feel a bit like this when we meet an application. Do you think that boulder up on the hill was in their design for this particular application? I don't think so. It wasn't in their threat model, right? And sometimes things come out of left field we didn't think about. But when you have the idea and you're building a feature, it's your opportunity to think evil, right? And so let's look through a framework called Dread. And this framework was created at Microsoft, and they actually stopped using it in 2008, which doesn't mean that we can't use it, but it sets up a way of thinking about this. Basically, the Dread stands for how bad would the attack be, right? How easy it is to reproduce the attack, how much work is it to launch the attack, how many people will be impacted, and how easy is it to discover the threat. And if you go through those and you kind of score them, or not, right? This doesn't have to be some formal, rigorous process. But if you take yourself when you're building that feature and you just think about these things, even just for a moment, you've become more security-minded than you were yesterday, right? Like you've already made that transition into becoming better at what you're doing. You can formalize it and do these things about like how bad would it be. Maybe this one of our users publishes an NPM token to GitHub. Like, that's probably a bad day if you have a bunch of packages, or maybe our NPM users' password is guessed, or our GitHub users' password is guessed, and we don't have two-factor auth on. You start thinking about these scenarios, and you have to, how bad would they be? How important it is, because that helps you weigh if you need to fix something, if you need to add another control or another way of securing it. And so when you need to think evil, right, one thing you need is knowledge about how to be evil, right? So one of those ways is reading about historical bugs. On npmjs.com, we have the the NPM security advisories, and they're a way of looking at past reports. And you can see detailed proof of concepts from some of the reference links to be able to read through how people did different types of attacks. And if you go you say, well, I'm building something that talks to the file system, right? And it takes user input and it reads a file. You can go look at different types of attacks that impact file system, and well, you might learn something, and you might say, oh, I need to change my code this way, right? It helps you think a little evil, and that's one of the best ways that I've found is looking at past attacks. Another thing that when I'm starting to build a feature are to like reminder phrases. A user would never, or I'll do that later, or I don't need a test, it's fixed now. Those are all trigger phrases that you can use to say that should smell funny, right? Like, I need to do something about that. If you say a user would never, they're going to. Like, that's exactly what they're going to do. And if they're not going to do it, an attacker's going to, or I'm going to as a tester. So that's yeah. So that's the beginning of your feature, right? Now you've written some code, you've thrown it in your editor, you made a commit, you submitted a pull request. This is the other gate that I find is extremely valuable in becoming a more secure developer. So we got, again, 10 lines of code, 10 issues, 500 lines of code. It looks fine. That's code reviews, right? Back when I worked at Symantec, this was 10 plus years ago, the kind of rate was to do a security review of a piece of code. It was 8 hours for 1,000 lines of code. Are you doing that kind of diligence for the pull request reviews that you do, right? Thumbs up is not a pull request review. Looks good to me is not a pull request review, right? you're not doing you're doing them a disservice because you didn't tell them what perspective you approached the code with. Now, my coworkers know that when I look at a piece of code that I'm coming from the security perspective because that's my role, and I don't have to explain that every time. But sometimes it's good to give people that feedback, especially if you now have done the work to start learning about different security bugs and you find one, you take the time to explain it in a pull request, you've now passed that knowledge on to your team, and now that starts to spread, right? Kind of like a virus, right? But for good. So checklists, right? Let's go back to checklists. Pull request reviews. This is what I tend to do. This is my checklist for pull request reviews. I look at what are the sources and sinks, what are the inputs and outputs, what new dependencies were added. That adds surface area, right? That's going to tell me what this does, what new technologies were added. It didn't read from the file system, and now it does. It makes HTTP calls, right? It takes user input. How does this thing work? How has the behavior changed? Does it have tests? Because it better have tests. This is where I'm going to mention tests. Just write tests. Your code will be better for it. So that's the next gate, right? Pull request reviews is sort of that midpoint in shipping code to production. And then you've got code in production, right? Or you've got it staged, right? And so I'm going to give you my sort of security auditing 101, because you don't have to be some elite hacker to do penetration testing on your own software. You can go look for bugs. This is the process that I sort of have distilled down over the years, many years. This is as simple as I can sort of make it for you, but how I approach things is understanding what the code does in the threat model. You look for inputs, because that's where you can talk to the application, right? A lot of things that we're going to build they take HTTP requests, query parameters, file uploads, things like that, right? You identify where that goes, and you follow that data through the process, right? Is it properly input validated, right? Does this input end up in a SQL query? Does it end up in a file system? Does it make another HTTP request? You test it and validate, and you repeat, and you have patience, right? And the thing is just like I said, if you don't look, you won't find anything. You have to go looking and think a little bit evil. My favorite bug that I ever found in JavaScript land was in the Atom editor, and this is because I went looking. So in Atom, when you download packages like native extensions, or I don't know what they call them, it pulls down a dist to compile native extensions. It pulls down like a dist file, so it pulls down Node, right? And it pulls it from their URL. So it's in the configuration. It says HTTPS, whatever Atom, .org or whatever, and but it's HTTPS. So if I did just a visual inspection, it's fine, right? It's just coming over a secure connection. But when you instrument that code and say like a container, and you look at the connections that it's making, when it hits that Atom, that HTTP endpoint, it would do an HTTP redirect to an S3 bucket. And so you could man in the middle or machine in the middle an Atom editor install, and you could get code execution on that developer's machine. Super fun bug, but I wouldn't have found it if I didn't go looking, right? And it was just to, was an experiment. I had no idea I was going to find something. It was fun. So tools. We've gone through some choke points along our process from development to production, and now we're going to go on to some tools. So we know, based on our survey, that 52% of the 16,000 people that responded to the survey aren't satisfied with the tools that they have to evaluate code. And so kind of a note on tools is that I'm not going to go into deep about a bunch of tools, because you need to know how to do these things. You need to know how to solve the problem. And you need to know what the tools do for you. Tools help help you remember, right? So they can help you, just like our alarm, right? It goes off, and it can help you during, say, test, or it can during a pull request, right? You get that pull request, you get a signal. I need to review this. If you add a linter into your pretest, your NPM pretest, and it fails, it tells you, oh, I need to clean up my code before I commit it. Or maybe at git commit, you have a hook, right? Those tools can help you there. And tools also help you be efficient. They can also augment your knowledge, right? But that can be dangerous, because if you just sort of take the output of the tool for granted, that can be dangerous too. You might be sort of lulled into a false sense of security. So you need to know their limitations of the tools that you're using. So the best tool that I can talk about today, since I'm from that NPM place and we do something with JavaScript, I'm going to talk about NPM Audit that we added earlier this year. This was the first contribution that my team made into NPM when we joined. We do roughly 3.4 million checks a week. 51% of those contain at least one vulnerability. That doesn't mean that it's exploitable necessarily, but it's there. And 11% contain a critical vulnerability. Again, they may not be exploitable, but maybe. We do this through NPM install. So every time you run NPM 6 or higher, you run NPM install, you get a little warning there. You get the number of found vulnerabilities. And then we also have NPM Audit, which gives you a little more detail. It tells you where in the dependency tree we found it, if it was some nested dependency, if it was a top-level dependency, and then where you can find out more information. Again, it's pointing to those advisories where you can learn more. But this is the magical part, is that NPM Audit Fix. We can thank the CLI team for this. They made it so if we know what version to tell you to update to, it just magically does it. It looks at semver and it will patch your package lock JSON and install those so that it gets rid of them. And now it's not perfect, but this is a case where we have it's a solved problem, and you can take the tools sort of like for granted, which is really nice, and you get lots of benefit from it. So NPM Audit Fix, and that's early on. That's about as far left as we can get in the process, right? It's during development time, right when you're bringing in those dependencies into your tree. We can tell you the status. And there's piles and piles of other tools, and I'm not going to go through them. I'll list them quickly. Linters, right? Keep your code clean and readable. Complex code breeds bugs. Pre-commit hook, again, a signal right before you commit something. You can add a script or something that you want to test something there. We have these ESLint plugins for security. They're not meant to be run during, like, say, CI, but they're good for just like an audit, because you're going to get a bunch of noise. So you have to kind of go through them manually, but it's useful. Security headers, SSL, web hint. I just learned about this the other day from Kyle. And there's look for secrets you might have committed in your Git repo, kind of automatically, right? These are all things you can sort of level up your game, and that cycle never ends. You're kind of always just falling up that escalator, I guess. So all right, my slides tell me to get to the point already. So wrapping it all up, right? Essentially, you need to set yourself up for success by interrupting yourself between idea and production, right? You need to set up those reminders so that you can build better habits, right? Before you write any code, think evil. Get and give good code reviews, right? A diverse team helps with that. Diverse perspectives help you ship better code. It's freaking science. Use tools that you know, but what they do for you. You do or do not do for you. I don't know what I was writing there. Oh, one more thing. You're also going to fuck it all up. You're going to write bugs. You're going to have a security bad day, right? And this says, now pet friendly, except for bears. We're not making that mistake again, right? Every sign has a reason, right? But you're going to make mistakes. Learn from those mistakes. That's the point of that cyclical process, right? Is that once you learn from your mistakes, you get better. You become security minded. You spread that to other teammates. Thank you.